Hello everyone, this is KP the Math G here, and we're about to work on, I just was looking on my how many videos I've got. This is going to be the 189th video, and it's all AP calculus based. It's all been that way, and so I want to do some more of these free response questions, but I think I'm going to end. I'm going to probably stop at 200, and around close to 200 I'm going to give you just an overview of what to look for in different things. You know, when to take a derivative, when to take a do an interval, when do you do a limit, and so on. So anyway, that's what I intend to do, and kind of give you some review of, say, when we do derivatives, do the product and quotient rule and the chain rule and so on. And then when we get to antiderivatives, show you how to take one from a basic one to some that are even more difficult to do. So that's kind of my intent. We may do something and show you how to do a related rate problem. That's probably going to be the last 10 that I intend to do. But we're just going to ride this roller coaster till it ends, and after 200 I'm probably going to do some algebra related stuff, maybe trigonometry or whatever. I don't know what I'll do after that, but I'm going to do some other stuff and kind of add to it. Alright, well anyway, this is we're going to work on this problem. This is the 2026 video. It's a free response question number 6, and it has to do with a differentiable, twice differentiable table of f and f prime. As you can see, the table here, and this is supposed to be differentiable, which means that the function is, you got it, continuous. This is part D of this. I didn't put part D down, but this is the last part of it. I've done parts A and B together, part C, and now part D. Alright, so let K be defined by the function K at x is equal to x, the definite integral from 0 to x, t squared f at t dt. Find K prime at x, find K double prime at 3. So what we're doing here is we're taking the derivative of K. So that's what we're going to do here. We're going to take the derivative of K simply by putting down what you call a prime. When you do that prime, you're taking the derivative of the left side. And then we're going to take the derivative of this side too. Now when you take the derivative of, anytime you see 0 and x or some number in x like that, you know that this, and you got a bunch of t and f at t dt, you're going to take the derivative. I promise you, 100 times out of 100 you're going to do that. Okay? And this is a practice on the fundamental theorem of the calculus, which actually we did in part C. Anytime you take do a definite integral, you're going to practice one, or you got two parts of the fundamental theorem of the calculus. You're dealing with part A or part B, or part B and part A, whatever. I don't know what order it's in. Some books call it one order and order it one way, and another book orders it another way. So, alright, so here's how it works. We're going to take, let's do a different color maybe, okay? We're going to take the antiderivative, we're going to have to flip this over But anyway, here it is right here, k at x, k prime at x, k prime at x. Now when you just do this simply, it's just everything is the same. All you're doing, instead of t squared, it's just, all you're doing is this is t squared, and instead of t squared, it is x squared. Okay, x squared, and then of course the 0, you know, we don't deal with that one. So it's just x squared and f at x as is. That's it. That's it. And you just plug the x in to here and here. Okay. Now if it's been like a 3t, you would have a 1/3 out here. If it's been a 1/3 t, you'd have a 3. You just flip, flip the sign. Like a 2/5, this would have been 5/2 out here in front. Just kind of something to help you understand what to do when you see that. But you just write it as is right here. There's nothing to do. You've done it. You have actually found k prime at x. So now we're going to find k double prime. Well, first of all, we want to find that. So let's flip the board over so we can have a little room to do that. I don't think I'm going to have room here. So k prime at x is x squared times f at x. Okay. Alright, so let's deal with that. K prime at x. Bear with me, I've got to move this forward to flip it over. There's a story behind this blue curtain thing that my wife hung up several years ago. But I'll tell you about it in just a second. The bed was turned, not this bed, but an older bed was turned this way, and so this thing hung down. Okay. But now it still hangs down, and the bed is turned this way. Alright, so here we go. We had k prime at x was equal to, what was it? I have to look. I know it's f at x here. X squared. That's it. F at x. Okay. That's it. Okay. Now, this is times. So let's find, if we're going to find k double prime at 3, we got to find k double prime at x. That means take the second derivative is what that means. And we're going to take the derivative of this. What do we do? It's a product here. So if you come out and say, oh, KP math G, let's do the product rule. That's what we're doing. Okay, so you could say either way it works out. You can, this is the first, this is the second. You can either say the derivative of the first times the second plus the derivative of the second times the first. Or, if you want to, since multiplication is commutative and addition is also commutative, you could do it this way. You could say, well, I'll leave the first one alone and just take the derivative of the second. Okay? Plus sign, always a plus sign on product rules. Then we'll say, take the second times the derivative of the first. And you still have exactly the same thing. You read it backwards, derivative of the first times second plus the derivative of the second times the first. So either way you go with that, you got it right. So the product rule is pretty much that. Alright, so let's go ahead and do that. I'm going to go ahead and leave that up there. And let's move our K double prime down so we'll have a little room to work. Alright, there we go. K double prime. K double prime. Alright, here we go. Let's do it this way, it doesn't matter. Derivative of the first, okay, so remember we take the 2, multiply it by the 1. 2 times 1 is 2. Take away 1. So x to the 1 is just x. Alright. Derivative of the first times the second, do nothing to that one. Plus derivative of the second, which is just f prime. That's all you do to it. And then times the first is just x squared. Okay, there it is. But it says find k double prime at 3. Alright, second derivative. If you're dealing with a first derivative, you might be talking about in terms of a graph, whether it is increasing, is the graphing, is f, or in this case k, increasing or decreasing. And then the second derivative, you were looking for a variety of things. Is it concave up? Is it concave down? Okay, and is there, where are the points of inflection if there are any? All sorts of things. Or the first derivative could be, in one case, if you're dealing with motion, okay, uniform motion. The first derivative might mean, say, well, the first derivative is dealing with velocity, and then the second derivative is acceleration. All sorts of things. Okay, well, let's go ahead and look at this. All we're doing is plugging 3 in. So 2 times 3 times f at 3 plus f prime at 3 times 3 squared. And that's all you're doing. You're putting 3 everywhere there's an x. Well, I need to go back to my table over here, and I'm not going to flip that over for that. I'm just going to look at this here. I find that here's x, here's f at x, here's f prime at x. So when we look at 3, which is somewhere over somewhere, but when we look at 3 here, we see 8 down here and 9 here. So f at 3 is 8 and f prime at 3 is 9. So we've got everything there. 2 times 3 is 6. F at 3 is 8. F prime at 3 is 9. 3 squared is 9. So what we have is 48 plus 81. 8 plus 1 is 9. 4 plus 8 is 12. So 129. There it is. Alright, there it is. It does test your ability. This is really a test to see if you understand how to take that derivative of the antiderivative a while ago that we just done. So you were tested with that. Then you were tested, can you take a second derivative and then find k double prime at 3. They just asked for k double prime at 3, which means you got to find k double prime at x first, right? And see what that looks like. Then right here and here, you need to look at the table here and here and see what it says. F at 3 is 8, f prime at 3 is 9. Make sure you put them in the correct places. Alright, don't put 9 here and 8 here. Alright, so 6 times 8 is 48, 9 times 9 is 81. This is just plain arithmetic. 48 plus 91 is 129. And there it is. So that's it. If we were testing, which that's a big number, but you know, if we were testing, say, concavity, since this is positive, your graph there is concave up. There you go. Alright, so graph of K, concave up. Alright, so there it is. Well, I could say a lot more, but that's going to be sufficient to tell you everything you need to know about this. You need to know how to do the product rule. Then you need to just know how to plug the number in, find these answers here, and then there you go. So they tested you on a few things, on your ability to do a few things. Alright, ladies and gentlemen, that's KP the Math G getting ready to sign off. If you want to hit that subscribe button, please do so. If you would like to make a comment, please do so. If you like to hit that like button, I just smile all over when I see a like. Other than mine, when I look at it, I like all my videos. I do like it. So if I get 5 likes, then I know one of them's mine. So really, I just got 4 likes from everybody else. Anyway, KP the Math G signing off. Ladies and gentlemen, have a great, great day.